Lesson 10.2, Task 2. So we're going to solve exponential equations graphically. All right, so it says another way to solve exponential equations is to use a graphical approach. You have solved several different types of equations in one variable using graphs, including quadratic and other polynomial equations. Recall that the technique for solving an equation graphically involves setting the expressions on each side of the equation equal to y and graphing the resulting functions together on the same coordinate plane. Whether using graph paper or a graphing calculator, you then locate any point or points of intersection. The x-coordinate of any point of intersection is a solution of the original equation. The graph shows how this method worked for the equation x squared minus 8x plus 13 equals 1. All right, so the graph shows that the equation has two solutions, x equals 2 and x equals 6. So again, it's the x values of the intersection point, so 2 and 6. So what they did was they graphed this equation, which is a quadratic, and then they graphed y equals 1, which is this red line. And then again, the two intersection points are your solutions, or at least the x values. All right, this graphical method can be used to solve an exponential equation in one variable. Solve the equation 6,000 equals 8,000 times 0.95 raised to the x power. All right, so we know this is exponential decay because this number is less than 1. All right, so use a graphical approach. All right, so we're going to set y equals to this side and y equals to this side. So it says what two functions will be graphed together on the graphing calculator. So y equals 6,000 and y equals 8,000 times 0.95 raised to the x power. What will the graphs of the two functions look like? How do you know? Choose two graph descriptions and two explanations. All right, so we know that y equals 6,000 is a horizontal line, and we know this one is exponential decay. So it's going to be a curve that's going down, and like it's going to be approaching 0 as it goes towards positive infinity. All right, so what do the graphs of the two functions look like? So we know that we're going to have one is going to be a horizontal line, and that's going to be the 6,000, y equals 6,000. And then another one is a curve decreasing steadily down and to the right, a curve increasing steadily up and to the right. We know it's a decay function, so we know it's going to be going down. We know that we have 6,000 is a linear function with an undefined slope. Well, if it's a vertical line, it's undefined. Remember, horizontal is a slope of 0, so it's actually going to be this one instead of that one. And then y equals 8,000 times 0.95 raised to the x is exponential growth. If this number is greater than 1, it's growth. Since this number is less than 1, we know that this one is decay. So this one has 4 correct answers. All right, so then they've graphed the y equals 8,000 times 0.95 to the x power. And then when you graph the horizontal line at 6,000, we can see that it's going to intersect right about right in here, okay? All right, so the graph of the function is shown. How can you use the grid lines in the figure to estimate the solution of the given exponential function? Well, again, if we know that 6,000 here, we can look at this line here, and this is going to be about, let's see, I would say about 5.5, okay? All right, so find 6,000 on the vertical axis, because we found 6,000 here. This is the vertical axis. We made a horizontal line, but you find it on the vertical axis here. And you move horizontally to the right along the grid lines until you reach the curve. Then move vertically down to lead you to the x-axis. Estimate the x value of the location using the scale on the horizontal axis. So that's exactly what I was doing here. I was looking at this horizontal line here, come over here, and then I brought this down here, and then I would estimate that point, which is on the x-axis. All right, so it says graph the function together on a graphing calculator and then draw them below. All right, so let's draw them on the graphing calculator. All right, so let's clear out what I had in here before. All right, so I'm going to graph 8,000 times 0.95 raised to the x power. And then my other line is y equals 6,000. Then I'm going to hit graph. This is from the previous graph, my scale, so I don't know what this scale is, so I probably need to change my scale again. You can see here this goes up to 10,000 because this is 8,000 and that's your y-intercept, so we're going to go up above that, and this goes over to 14. So this is my x, this is my y, so in your calculator, you can go to Window, and my x minimum, I don't need very much of a minimum here because I'm not going to be on the left side of this. So just change the maximum to 10,000. Oh, wait a minute. Nope, sorry. That's my x. Clear. Change my x's to 14. And then you can leave it as a scale of 1 if you want. And then my y minimums don't need to be much, but my y maximums need to be 10,000. All right. Now when you hit graph, you should be able to see the horizontal line and the exponential decay line as well. All right, again, and you can see right here is where they're going to intersect. And since we're looking at the calculator, let's go ahead. On your calculator, if you hit second trace, there's a button here that says intersect, and if we choose that, it's going to say first curve. So you can see it blinking right here. The first curve needs to be to the left. It reads from left to right, so move it to the left and then click enter. And then it says second curve, so we're going to arrow. Doesn't matter which line it is. We're trying to find this intersection point. We just need to be to the left and to the right of this point. So I'm going to hit enter again. Now it's going to say guess. So you actually have to hit enter one more time. And this is going to give you the intersection point, okay? So it says the intersection point is 5.6 and 6,000, okay? So the graphing calculator is very handy. I'm not going to try to draw that on here since we did it on the calculator. All right, so it says use the graphing calculator to identify the point of intersection. What are the coordinates of this point? Round to the nearest hundredth, okay? I rounded to the 10th, so I need to look at this again. 5.61, because 8 rounds up, so 5.61 and 6,000. And that's the intersection point. And the x value, 5.61, is the solution. All right, so it shows that it's been graphed on here, and it shows that intersection point as well. All right, so what does the point of intersection reveal as the solution of the original equation? How can you verify that this value is indeed the solution of the equation? All right, so you can go back to your equation and you can plug x in, and it should be approximately 6,000. So if you take your equation, wherever it is, right here, if you do 8,000 times 0.95 raised to the 5.61, I believe, and you hit enter, that should give you about 6,000. Okay, so again, we've plugged in numbers to check our answers, and that's another thing we're going to do here. All right, so your x is approximately 5.61. And we say approximately because we did round to get that number. This value can be substituted in place of x on the right side of the original equation to see the value is about 6,000. All right, it says, what are the benefits of graphing with technology to solve exponential equations over graphing using graph paper? Well, your graphing calculator is going to draw that curve like nice and smooth. When we draw it on graph paper, we're probably not as accurate. So graphing calculator probably is just a little better. All right, if you have any questions, please let me know.